Hello, we are Team Holly, and we're going to present our project Water Level Controller with STM Microcontroller. The team members are Jesse, Jasmine, Nicholas, and me, Eric.
In this project, we model a water level control system. We use 3 LEDs to simulate the water levels of the dam. Our program itself has numeric value for the height of the water and will trip 4 imaginary sensors. We also use 2 LEDs to simulate power being sent to heavy water release gates. This device will run a continuous loop correcting the status of the gates and water level indicators when the water level is becoming too high or too low. For emergencies, the system will enter a finite loop, opening both gates to prevent overflow from ever happening and shut off the system.
So here we have our block diagram, and the modules on the right are actual inputs. On the far right, you have the emergency shutoff switch, and then on the left, you have the level of sensors. These are all simulated virtually, and if you look down on the bottom, the green, yellow, and red overflow modules, those are the outputs, and on top are the gates, and those are outputs as well. And using the UART software, we implement that to connect the Nucleo to display our values from the PC.
So this is our state machine diagram. So we start at idle, and we always move instantly to emergency cutoff switch, and it checks to see if that one's activated. It only activates in an emergency, obviously, and when it does, it opens gate B and it opens gate A. It then turns off all three LED indicators, and then it just stops the program. But without the emergency switch, we go to green. It checks for green. If we get to yellow and it doesn't reach yellow, we follow the green path. This is higher than 0, water level 0, where we get green LED on, and the emergency gate B closes, emergency gate A closes, and then we go back around. In case we go up to past yellow and we reach the red level sensor and it checks to see if it meets that criteria, we reach higher than 5 water level. So we get to green on, yellow indicator on, gate A closes still, and gate B closes still. Again, we move around and then we reach past the red level sensor check. We reach higher than 10, water level 10. And then in the case of not meeting the emergency sensor, we just follow the third path, which is all 3 LEDs are on, and gate A is open, but not gate B. And then we loop back around in a check one last time for the emergency one, where if it's higher than 15, we go through all LEDs turning on and all gates opening, and then it just repeats this cycle.
The team met together and created a final project description and discussed how we want to create and realize this project. Also, the team looked for different options to implement the idea of our project in the circuit. Taking those ideas, I implement the circuit and I program part of the code for the project. We then met together and did troubleshooting and future implemented an emergency fail switch into the code and breadboard, as well as troubleshoot existing problems with the foundation code. We then, as a team, worked on the final project report as well as the slides. The overwhelming majority of the project was done together as a team in group meetings where we could communicate and provide feedback, input, troubleshoot, and make changes.
And so here we have a couple of pictures of our physical circuit being implemented with the STM microcontroller. So looking at the picture on the right, we have two LEDs that are lit up. Those are actually our emergency brakes or emergency cutoff levels. The LEDs that are turned off are indicators, respectively green, yellow, red indicate 0, 5, and 10 levels of water. And so the push button on the far right indicates that the system is shut off. So that's like the worst case scenario.
All right, so we have the demo video, which is right here.
So we are Team Holly, and we are going. We have a dam, and we have water level sensors and 2 gates. So our water gain for now is going to be 0. So next we're going to go have a rainy day. So we're going to have a water gain increase. Okay, so now we see how the water level increase. It's increasing. So now when we reach 5, the second water level sensor is on. We're still increasing. When we reach 10, we turn on the third level water level sensor and we open the first gate. So we have the water gain same and the water level is not increasing too fast as before. So now when we reach 15, the third water level sensor is on and we open the second gate and we are going to see now. So now we're going to decrease the water gain back to 0. And we're going to see what happens. So when we reach 10, we close the second gate and we're still like bringing water. And we go back to the second level water sensor. So we don't have any water gain. We go back with the low level water sensor. Now we're going to press the emergency button. So this is going to be, this is going to shut down all that program and keep the 2 gates open. Okay, eso sirve. That worked.